Okay, and welcome to your video tutorial on scientific notation. Today we're going to have a look at what scientific notation is and how on the earth it is related to indices. Okay, so it's very common in the world today to be working either with very large or very small numbers. Okay, it happens all the time. For example, the number of cubic meters of concrete used to build a big massive dam, the Hoover Dam for example, was 3,400,000 meters cubed. The mass of a molecule of water is 0.0000000000000000029 grams. A tiny number. So we've got tiny numbers and huge numbers. Sometimes these numbers can be written more simply by using powers of tens or using indices with either a positive or a negative. We call this form scientific notation or standard form. Okay, so just a quick little example here. The Intel Core i7, which is a computer processor, okay, the number of processing die transistors it has in it, you don't need to know what that is 731 million. Now, instead of writing 731, 1, 2, 3, 1, 2, 3, that big whole long number, we can actually just write that as 731 times 10 to the power of 6, okay, or with 6 zeros after it. Now, you might have come across scientific notation. Sometimes when we get a really big answer or a really big a small answer, our calculator sometimes by default turns it into scientific notation. Today we're going to have a look at the way in which we can take those original numbers and turn them into this standard or scientific form. Numbers written in scientific notation are expressed, like I've said, as whatever the number is multiplied by 10 to a particular indice. Okay, large numbers will use positive powers of 10. So 38 million years, if I expand that to write that out, that's 3, 8, 1, 2, 3, 4, 5, 6. Okay, that's 38 and 6 zeros. Okay, and I write that as 3.8 times 10 to the 7 years. Interesting. Small numbers use negative powers of 10. For example, 417 nanoseconds is the same as writing 0.000000417 seconds. And I write that as 4.17 times 10 to the negative 7. Okay, so smaller numbers where the significant figures come after a decimal point, I read it in a negative indice. Now, let's have a look exactly how I got 3.8 from there and 4.17 from there. To write numbers using scientific notation, we place the decimal point after the first non-zero digit and then multiply it by a power of 10. So if we look at 2,178 kilometres, it's the same as writing 2,178,000 metres. Okay, so if we want to express this in scientific notation in metres, okay, how could I do that? Well, let's have a look. Okay, I'm placing the decimal point after the first non-zero digit. Okay, so my first non-zero digit, we'll do that first. My first non-zero digit is here, and I'm placing my decimal point there. Okay, now I need to count how many digits I have that is after that decimal point. 1, 2, 3, 4, 5, 6. Okay, so there's 6, so my answer becomes 2.178 times 10 to the 6th. Okay, because I place my digit after the first non-zero digit. By comparison, if we look at 38 microseconds, which is a millionth of a second, I can express that as 0.00000038. Okay, I look for my first non-zero digit, okay, and it's the 3 there. Okay, when I'm rewriting this in scientific notation, I know I'm going to be putting my decimal point at this spot here. Okay, I need to count how many decimal places it is, how many digits are between my decimal point, okay, and that after that first non-zero digit. So when I count, I go 1, 2, 3, 4, 5, 6, okay? So my answer becomes 3.8 times 10. Now, because it's a smaller number, it's to the negative 6. Okay, so let's have a look at these two exact examples, okay? It's saying 4,500,000, express this in scientific notation. Okay, so I know it's going to, my first non-zero digit is this 4 here, so my decimal point in my scientific notation is going to go after it, okay? And I'm looking for how many digits are after that 4, or that first non-zero digit. That's 1, 2, 3, 4, 5, 6. So it's going to be 4.5 times 10 to the 6th. Okay. Equally, I look at this one. My first non-zero digit is I only have 1, and it's a 4 here. Okay, and I know it's going to be going after the 4. So it's 4 times 10 to the 1, 2, 3, 4, 5, 6, 7th. Okay. 4 times 10 to the negative 7, sorry. That's a really important thing, guys. You saw that mistake I just made. I wrote 10 to the 7th, but it is a smaller number. Always make sure smaller numbers, negative indice, bigger numbers, positive indice. Okay, what happens if we were asked for these? Express each of the following in a decimal form. So this is them in their scientific notation. It wants you to go the reverse way. Okay, so 9.34. Okay, so let's write down 9.34. Okay, and it's to the positive 5, so it's going to become a bigger number. So I'll go 1, 2, 3, 4, 5, which means that I must have another 0 here, and in here, and in here. Okay, so my answer becomes 934,000. That is 9.34 times 10 to the 5th. Now, 4.71 times 10 to the negative 5. So I'll write down 4.71. I'll write down 4.71. Okay, and now I'm going to move the decimal point, this time 5 places to the left. So that's 1, 2, 3, 4, 5. Okay, so which means I'm going to have, in these dips, this is where I'm getting my 0 digits from. Okay, and that decimal point is just going to be there on the end. Oop. Can't quite draw it in. So let's write that again. So it means my answer is going to be 0.123471. Okay, so it means it's going to have 4 zeros in front of it. And that's it, guys. That's scientific notation.